how do we know which bacterium are going to be susceptible to which antibiotics? There's a method known as the diffusion method. It's also called the Kirby Bauer method, and it's one we're going to look at for lab. So the Kirby Bauer method is one that we use to look at the effectiveness for an antibiotic on a particular pathogen, in our case bacterium. So in lab, you're going to be looking at 4 different antibiotics to the susceptible in your bacterium, which is going to be, is it susceptible or resistant. Now I'm going to stop here for just a second, because what's going to happen is, because we're doing this virtually, is you're going to be prescribed an particular bacterium. I'm going to send that to you through an email, and you're going to be told the 4 different antibiotics that you're going to be performing this test on virtually. Okay, so you need to watch a video. I'm going to walk you through it, but you also need to watch a video. Imagine if you were doing that in lab, and then what I've done is I've given you the results. Okay, so let's talk a little bit about this assay. It's known as the Kirby Bauer test. It's also known as a diffusion. Why? Because in the Kirby Bauer method, you're going to use a specific auger plate known as a Mueller-Hinton auger. The Mueller-Hinton auger plate is specifically designed to allow for a paper disc that has antibiotics penetrated throughout that disc, so that when you put that disc onto that Mueller-Hinton auger, it allows the antibiotic to diffuse out over a specific concentration gradient. So if you look at it compared to where the circle or the disc is, it's going to be very heavy there, and as that antibiotic moves out across that auger, it's going to diffuse and have lesser amounts. Then what happens is, as the bacteria grows, it's going to, if it is resistant to that antibiotic, nothing's going to happen. It's going to grow all the way over or near up to that disc. However, if it's susceptible, it's not going to grow, because it's going to run into that antibiotic and it's going to stop or be inhibited from growth. That then leads a nice clear zone of inhibition, as we call it. Again, there is going to be a video that's associated with this that will help you see this. In that video, it walks through the procedures with you. Just going to briefly discuss them here for a second so that you have them in the PowerPoint and can remember them for when you're writing your lab report. Okay, so in this case, you're going to take a broth culture, so that means that the bacterium is growing in a liquid. You're going to put some of that broth culture onto a cotton swab, and then you're going to take the Mueller-Hinton auger, and if you were in lab, you would have been then swabbing that auger all the way across it and doing a field, as we call it. So you're going to be going all the way across it. You'll probably actually get and rub that bacterium over that auger twice to make sure you have a solid coat of bacterium. Then you're going to go in, as this picture down here in the left corner shows you, you're going to take paper disc that have a certain amount of antibiotic on it. You're going to put those discs on the plate. You're going to then cover the plate. You're going to put it upside down in an incubator if you were in lab, and you're going to let it grow. Then what happens, as you can see in this last picture here, this 4th picture, is that the bacterium is going to form a nice solid growth all the way across the plate, except for where it is susceptible to one of those antibiotic disc. And then, as you can see here, there is a nice, what we call, zone of inhibition. You see it's yellow, kind of ivory all the way where the bacterium is growing, such as here, but here it's clear around this disc. That's the zone of inhibition. Notice they're using the metric side of the ruler, and they're measuring that zone of inhibition, and then they're going to use those measurements and they will interpret the results. Okay, so how do you interpret the results? So if this was the Mueller-Hinton auger plate and all of these were different antibiotics, and you can see here in some cases this represents a zone of inhibition. So in the case of this picture, the bacterium is going to have 3 zones of inhibition that you can measure. For the rest of them, where there is no zone, it would be 6 millimeters, maybe 5 to 6 millimeters, because that's the size of the disc. Okay? So then what happens is, for these that have a pure zone, you're going to take the ruler, you're going to come across and you're going to measure it, such as you see here, and you're going to use metric system, so millimeters. Okay, so in this case it could be 15 millimeters. All right, and you would use that one. In this picture, for instance, the disc is just slightly different, so it's 5 millimeters, but then the zone all the way across, you're doing again all the way across the diameter of it, and it's going to be 9 millimeters. So you're going to measure these. So in this case it was 15, in this case it was 9 millimeters. What do you do with these results? Then you're going to take these results and you're going to determine if it's susceptible, intermediate, or resistant based on the chart. Let's just say if we were back here that we were using this first zone right here that was 15 millimeters, and we're going to say your bacterium is Mycococcus luteus, and the first thing we're going to do is, let's say if it was 15 and this was penicillin. So we're going to go to the chart and we're going to say P is for penicillin, and the results I gave you were 15 millimeters. Now, again, I told you it was Mycococcus luteus, so we know it's not staph. If yours is a staph, you'll use the top line. All other ones, you use the second line. And at 15 millimeters, you'll come over, you'll look at your chart. This is 14 millimeters or less, but yours is 15. So you come here where it's 15 millimeters or higher. You will read it then as susceptible. Okay. On the other circle, remember it was 9 millimeters. So let's say that that circle happened to be ciprofloxacin. Okay, so if it was ciprofloxacin at 9 millimeters, so we'll find ciprofloxacin on a chart. You would come over and you would say 9 millimeters. Well, 15 millimeters or less is resistance. So then you would say it is resistant to ciprofloxacin. Okay, and just a word to the wise, it is the bacterium that is resistant or susceptible. It is not the antibiotic. So I didn't say penicillin is susceptible. I said that Mycococcus luteus is susceptible, or the bacterium is susceptible. And with that, that concludes this video for your antibiotics and the Kirby Bauer method.